Hello and welcome to the Nextflow podcast. This is episode 54 going out in February 2026. Today we've got a special episode together with Lorenzo Fontana. He's an engineer in Seqera and is quite a special background of deep expertise into how low-level operations within Linux happen. And he's one of the key people behind some of our core software within Seqera, namely Fusion and also the new Fusion Snapshots. Lorenzo works in a small group in Seqera with Paolo, who work on all the kind of crazy cutting-edge developments that we like to push out at Seqera. And he's got a really interesting background and insights into the kinds of problems that happen with bioinformatics software and how to solve them. In this episode, we're going to go a deep dive on how he got to that position. And we're also going to talk about Fusion and Fusion Snapshots and how Fusion Snapshots actually work. So, with no further ado, I'd like to welcome my guest, Lorenzo. Thanks for joining me on the podcast.
Thanks for having me. I am excited to be with you.
So, when did you join Seqera? And tell us a little bit about what you do.
Well, I keep on saying I recently joined. It's been a while. I joined more than 1 year and a half ago. Seqera was very different. Like I was not coming from a biotech background. I've been working in Linux observability and security for a long time. I am the author of a book with O'Reilly called Linux Observability with eBPF. He told me that I don't have to give for granted the acronyms because everybody doesn't have a little book with all the acronyms, so we do them all the time. BPF stands for Berkeley Packet Filter. I'm a subject expert of that. It's a technology in the Linux kernel that allows you to interact with the kernel, get information and do certain activities from a kernel point of view, but without writing a kernel module. Usually we write programs for our computers in Linux by writing them user space. We just compile and run them. It's very nice to be able to write them for the kernel itself so that they run at that level, but it's also very hard to do because then you are going to break the machine if you do it wrong.
With
VPF, you can do it without breaking it because it's a virtual machine.
Where does the name come from, Berkeley Packet Filter?
Berkeley Packet Filter because initially this was developed for a very different reason. It was a generic Unix feature developed for Unix, not for Linux, that would allow you to filter packets. No? Think about TCP dump. TCP dump is a utility in Linux that allows you, back at the origins, that allows you to see the packets going through a network interface. The ability to make firewalls and make and filter packets and see what is going on in the network was one of the first use cases for it. Was one of the first needs that people had, because they wanted to be able to block packets and see what was going on. So there was this syntax for users that was like, if IP source this and port source this or port destination is 80, block or allow, do this. And there was this language that was essentially an instruction set that was very accumulating on a variable, and it will take a simple decision. Now eBPF, which is eBPF, so extended, is all in the Linux kernel, and it is a lot more complicated. The instruction set is bigger, is more complete. It's more similar to more high-level instruction set, but still not as powerful because it has to run in a controlled environment, which is the eBPF virtual machine that runs in the kernel. So you can put your programs in a virtual machine inside of the kernel. I hope I answered your question.
So it's kind of basically a filtering level that filters all the data that's going in and out of the kernel, so you can modify how base level processes happen on the OS. Is that right?
Initially, it was called Berkeley Packet Filter because that was the capability. Now you can do things, for example, like attach to a function in the kernel every time it gets called, give me the variables. I've met a situation where there was something, not allowing you to do something. No, you don't have permissions. You search and then you have, write this a Parmor rule, write this Linux rule, just to bypass it or disable it. All of this is there for a reason because processes don't have to go wild and now it's even more important with AI, no? And there is the ability with BPF LSM to actually change how a process behave, no? And what it can do, block certain executions. You can nowadays pretty much do anything, no, that you could do with a kernel module. It's becoming more like writing a kernel module than what it was before, no? So packet and filter now are just in the name.
Okay.
It's because it originated from that idea and from that concept.
Nice. So you don't have to do sudo go make me a sandwich from xkcd.
Yeah, no, it's more like I don't know. AI agent, please disable this because it's getting in my way for doing my research. And I'm trying. I've always been trying in my career to make sure that users are able to not disable those things because they are important to have. So they can be secure and they can be doing their work without having security in their way.
How did you get to be an expert in this? It's obviously it's pretty niche. It's pretty low level. Like, what took you to this point in your life where you ended up being an expert on eBPF?
A question that I love because I remember the epiphany for it. I had a colleague called Ed at Influx Data. He was a very talented, he is a very talented engineer. He is able to do reasoning that still is unknown to me. No? And he was writing the storage engine for InfluxDB 2.0. And the storage, writing a storage engine for a database is one of the most rewarding but difficult tasks that you can do. And when you write a storage engine for a database, you have to take into account the fact that people are going to run the database, no? And they are going to use it against an actual storage medium, a disk. I was an essay reader, no? Site reliability engineer for the book of the acronyms, no? And this guy asked me, can you tell me, no, when the storage engine writes to disk, how big is the actual write to disk? Because when you write with a Linux syscall, you issue a write syscall, no? And you're saying, I'm writing this chunk of data. I'm saying, I'm writing these 10 bytes, no? But how are those 10 bytes flashing from the VFS, book of the acronym, virtual file system, to which is the abstraction in the Linux kernel that is given to file systems like ext4, ZFS, or this. This is the abstraction layer. How is then translated this to an actual physical write to the medium, no? Because this is important because for example, disks have a fixed capacity, no? Their throughput is limited. But with all this in mind, I just wanted to know if I issue this write, what is happening? And I started scratching my head, like because we were porting all the infrastructure to Kubernetes, to new mediums, because it was changing, no? And there were no instruments. Like, what do you do? Write a kernel module to know this. I started researching, and I already, even before, used the eBPF for other things. It's like, why don't I give a try to this? I started being loud about it. I made a project for this specific reason, which is called QCTL Trace, which then got donated to IOVisor, which is a group in the Linux Foundation. If you go on GitHub, IOVisor kubectl trace or kubectl trace, it allows you to run BPF programs in your Kubernetes cluster. In particular, back then, I used BPF trace, which is a way to write BPF programs with a DSL, no? So you can just like write a small program without having to compile, without having to create a loader. There are a lot of things that you have to do to make a BPF program work. So just load this program to all your nodes in the cluster, and the program was tell me this. So I got excited, probably for my colleague, it was just a small request. Who cares? Tell me, no? But for me, it was an addendum to my own set of things that I like to call myself a deep generalist, no? Because I tend to do many things. I feel like that knows this as Seqera, like I can make OS up or do something else. In the meanwhile, go in depth with a specific feature in the kernel. And I tend to do this, no? So this was something that I could dig deep into, started doing it, started being vocal about it. At some point, I had the opportunity to write a book with O'Reilly, and that changed things a lot back then because there was not a lot written on eBPF. So I studied a lot, low-level networking and how things work in the kernel. And the eBPF gave me the opportunity to study those low-level things for a reason, because the eBPF is touching every area of the kernel because it can interact with all other subsystems. In fact, it's a subsystem itself, but interacts with all of them. If you enter, a subsystem for, networking, you don't touch file system, you don't touch other things. So it's perfect for someone like me who defines themselves in that way. And so I got excited, started writing the book. The book had me like sit down for hundreds of hours and study because there was no AI. I could not just prompt and say, I want to like help me research and let's do this and let's do that. I just had to go in the code, look and understand, and probably some things that I wrote or I said or I'm even saying right now are still wrong because you learn every day. But at least I got that. Then when you do things, when you get the ball rolling, you start working on things. Started working on Falco, which is quite popular. It's now a graduated project in the CNCF, Cloud Native Computing Foundation, which is a branch of the Linux Foundation that is doing cloud native tools. And being a maintainer for a tool like that allows you to really, be with the community and understand the users. And I really liked it because it was kind of, doing security, for a community that is, vibrating around it, is creating solutions and is creating, giving you new problems. I remember one day I was on Lake Tao at the house of the founder of Sysdig, which was the company that was employing me, that was making Falco, like a company that created it. And I was on an issue that said, Falco makes my kernels crash. I did the mistake of going on Twitter because I just no filter sometimes. And I said, because I understood why, so I created a reproducer, and said on Twitter, I'm able to crash a Linux kernel with eBPF. And I started receiving DMs, direct messages on Twitter saying, like from new accounts, like, what did you do? What like strange things? Like literally threat actors. Like a few days later, one of the kernel maintainer sends me an email. Can you please the next time just tell us? Um,
Oops.
oops. And then we patched it and everything went the right way. I didn't disclose it irresponsibly. I just said it,
Yeah.
no, but I didn't say how at least, but and I was pretty aware that you have to do it. But sometimes the excitement, no, is just too much, to stay silent. And I didn't think about it. I was just like excited that I literally just boop, and the computer starts shutting down every single CPU until the last one, and then boom. It's like, oh my God, so nice. It was the first time I was able to do something like this, and then I started doing it more and more, but on different software, etc. But it was an epiphany as well. Um,
What took you from these positions of working on eBPF and kind of low level kernel stuff? What brought you to Seqera?
the Bernat, our hiring manager, is very good at his job. He reached out, and I immediately understood that I spent a lot of time, like I'm happy that I did, but I spent a lot of time uh, creating value in security and creating, security software and, making application run faster, etc., etc. But the mission that Seqera had of like making drug discovery faster, making research faster, has a deeper meaning in a way, for me. Uh, it's a little bit personal, but my dad died of cancer, so I had a little bit of, it's unfair, around there. It's unfair that people can access medications in different ways. Not everyone has the same thing. However, there is not much I can do in terms of actually making it happen for everyone. But the kind of customers that Seqera has, and the kind of situations that are around it can, and the kind of people in the community of Nextflow that are there, they totally can, So I said, why I don't try to put my experience in making things faster, making things smooth, more secure, these kind of things, or even create new experiences for myself, to serve a purpose that is, a little bit different than I did before. So I was like, let's try this,
I'm glad he did.
and and I tried it. It's just not like you, but everybody like you try different things. It's just I don't consider myself a static person, so I just try and see.
And you joined Seqera in the Fusion team working with Geordie, and I think I had Geordie on the podcast a while ago talking about Fusion, so regular listeners might recognize that name. And then we've had a bit of a shuffle at Seqera. So Paolo was the CTO, and now he's chief architect. And you're part of a special group, right? We're nicknamed the Magicians Guild, which I quite like, by Rob Newman.
Yeah, we are a bunch of people that, in general, we are very pragmatic. No, we like to get things done. We like to not float around stuff. Just like to do things. And Paolo is you know, is the most out of us. Like I look at him with that. Like I want to be like you when I remove from my brain all the blockers, that block my brain from being more pragmatic and accomplishing more in terms of not because you destroy yourself or do actually do more, but because you remove the frictions that your own brain have into actually using your time in the most productive way. I think. So yeah, now we are like in this asset, we are committed to do experiments. In my opinion, the world changed so much in the past few weeks, and Seqera planned for this already in the past few months for different reasons because we already saw it coming, and now we gotta do it.
So
So
tell us a little, give us an introduction to Fusion first off. Like that's central to a lot of the work that we do at Seqera.
left that untouched. Was this podcast supposed to be about Fusion and Snapshot, about me? So Fusion is an interesting name because there are so many things named Fusion. The first that comes in mind is the Dragon Ball no reference. But Fusion is essentially a file system. In the Linux kernel, there is a feature called Fuse file system user space, because usually file systems are not in user space. File systems are in kernel space. They are written as kernel modules, very consistent with my eBPF, and like I want to do things without breaking things. And it's not just a file system user space that exposes your files that you have in different cloud providers, S3, GCS, Azure, whatever. Like we have a lot of integrations, but it also is tailor-made to be aware of an Nextflow pipeline, of what happens, of how to optimize throughput for what the pipeline is doing and what Fusion thinks that the pipeline will do. No? Which personally, I tend to use it for all my interactions with buckets because it's just too annoying to go and do the things. And also because like sometimes you see blog posts are related to bioinformatics, but see blog posts, I need to delete 20 terabytes of data from S3. Oh, do this script, do that. Like, if you do it from the UI, it's bad. Fusion does the best way. No? Fusion has all the techniques to do it, the things in the most efficient way, the least expensive way, all these. And for me, it's a no-brainer to just use it.
The way I think of Fusion as being exactly like that abstraction layer. You don't have to think about the fact that you're using cloud storage or even multiple different clouds in one place. Fusion just exposes all of it in a way that I'm familiar with, which is really, really nice.
And it's been like exposing object store as a POSIX file system is the theme of this century. No? Yeah. Object store are optimized to put your data to multiple machines, be redundant, be fast, be cheap, not all of them. And POSIX file systems are just convenient to use because you write your programs and you cannot write the integration in every program. You cannot hope that every program does it well, or write the credentials to every program. Fusion is shipped via Wave, so you essentially augment whatever container that you have in your pipeline with Fusion. It's automatic, and I initially didn't get it, and because I'm more used to you mount a file system in the machine, not in the container. But I think it's a great idea because it binds the life cycle of data abstraction to the pipeline execution, which makes possible to do optimizations that are taken to an extreme. I don't think that, even though sometimes you don't see small optimizations, small incremental optimizations as a value added, I think that in Fusion, those are what make Fusion possible. No? Those and the fact that the team want to shout out to Jordi, but more important to Alberto, is very knowledgeable of Alberto Miranda. If you want to, Jordi was already in the podcast, but Alberto, no, I think, are extremely knowledgeable on POSIX file system, what happens and what, not everyone is like it. One thing that like people ask in interview questions that I've heard is like, do you know what happens when you open a browser tab and all the network connections, all the small bits, the DNS query, like who is replying first, who gives you the IP, what is the TCP handshake, all this stuff. And I can go with this question. Is a nice question, but because you see how a person goes in depth into all the levels and what is the view. I think that if there is a depth that you can go down, no, with POSIX and file system, Alberto knows the deepest point. It's like I don't know, it's in English, but it's like that point. The name in English, but it's the point in the ocean, which is the most depth.
Mariana Trench.
Yeah, the Marianne Trench, Fossa delle Marianne in Italian.
Yeah.
So it's literally that, no? So
but one of the things I was going to ask you, I mean, you talked about the Fuse file system, and we said how Fusion can make object storage appear as a POSIX file system. Like, Fusion isn't the only tool that can do this. People might be familiar with MountPoint from AWS, and I'm sure there are others. What's the difference between Fusion and these other tools? Like, is it the thing about mounting Fusion within a container? Is it the Nextflow optimization? Is it all of this and more?
I believe that, first of all, the easy one is that it's integrated in the ecosystem. It's a no-brainer to use. You just enable it and it works, which already for me it's a winning point of it. No. Second one is that the person making it are taking in-depth consideration more than anything else, more than even POSIX compliance, more than even building a good file system, no? The actual use cases for Nextflow, and not only Nextflow, but for the tools that usually people run in Nextflow. Like like other file systems, they are not that reactive to, I don't know, if pigz has this behavior, or if CRISPR-Seq doesn't work, or if in this way this thing breaks, because they are generalists. No, they are generic tools that you can use. No, and usually purpose-built tools are a lot more performant. The downside of purpose-built tools is that they are purpose-built. No? It's no, it's a limitation when you want to use them for things that are not their domain. But we are focusing on a specific domain. Otherwise, we would use something. We are not focused on making this perfect for allowing you to back up your Mac. No, we are focusing it for speed of execution of a pipeline, for making sure that it doesn't get in your way when you don't have enough CPU, when you don't have enough memory, or when you run multiple tasks in a same computer, when you run with the GPU. And we are stressing this with Fusion so much that it ended up becoming the center of another feature that we developed, which is called Fusion Snapshots. In the end, Fusion Snapshots, if you're not familiar with it, allows you to bring a task that is running on a machine and move it to a completely different machine in a transparent way. No, moving things requires a file system. No, with a normal S3 integration. No. Whatever it is, like another mount point or another way, like download, upload. How do you do it? No? And one of the challenges of Fusion Snapshots is that we wanted to do this in the time window where your instance gets reclaimed by by AWS, because Fusion Snapshot, the way it works now, that let's say you are on the spot market, you did all your settings, like maybe like you want to spend a lot less than your default, and all of a sudden the machine gets reclaimed. It goes in a loop, it gets reclaimed, gets reclaimed, gets reclaimed, and you end up spending more. No?
We talked about this a little bit in the last episode, and I was saying it when I started working with cloud computing, the spot market on AWS was there was plenty of capacity.
Relaxed.
It was very relaxed. So you just always put stuff as spot and didn't really think about it, and stuff was just like way cheaper. But the capacity I think it's become trimmed a lot more in recent years. And now if you run with spot on AWS, if you run a big pipeline, it's pretty likely that you're going to hit some spot reclamations. And without any snapshot stuff. So, I mean, what happens if you're using like any of these other systems like regular S3 or Mount Point or whatever, the task gets killed and Nextflow will retry it, but it just starts again from scratch. And if you're running an 8-hour process, you lose a lot of time and a lot of money. So you're saying
this stuff is only possible with
snapshots. So so tell us a little bit more about when you say kind of moving a task from one instance to another. Like, what do you mean there? What does that look like?
Very nice, because the stuff, it wasn't built for this, no? But Paolo had years ago the intuition of putting every task in a container, no? And containers are the perfect abstraction because you can essentially have a bunch of processes, no, that they are bound by the boundaries of the container, and they are together, no? And they are only dependent on each other most of the time, so they don't really interact with anything else than the processes in the container, the files in the container. Maybe they make some connection to the outside to download something, to upload something, but it's in a research pipeline. Like if you are researching something, you are usually transforming data or acting on data. Like it's usually self-contained. It's in functional programming we will call it pure, no? It's pure. When something is pure and contained because of the intuition of Wave, and the file system that you have is already available in other machines, because Fusion, if you write a file, it's available. Like you just stop Fusion, restart it in another machine, go to the same folder, it's there. No? So the intuition was, what if we, when the task goes away, just reuse the work dir in another EC2 instance? And what happens, however, is that like if you just reuse it, no? Then you have all the files, but you don't have the process state. You don't have the memory state. You don't have the file descriptors that are open. You don't have the network connections that are made. You don't have the kernel state, let's call it like this, of everything in this container. There is a technology in the Linux kernel called criu, CREU, no? Checkpoint Restoring User Space, acronym book. And criu is doing essentially this. No, but criu is not batteries included. No? So we, again, as other things, we made our own version, no, that is perfect for Nextflow pipelines, for tasks running in Nextflow pipelines. Hopefully, now we have also future plans for it, and we are going to execute them and experiment them. I'm a very big, proposer of let's try experiments and let's do these. And I think that it's very, aligned with the view of the world that exists now, and also with the audience that Nextflow has, with the kind of users that Nextflow had, because what are people doing in Nextflow experiments? In the end, like we don't know the answer, no? And as those experiments evolve, Nextflow and Seqera platform and the tools that the company Seqera provides need to change to go towards new ways, no? Now with AI, now with whatever will come in the future, no? Fusion Snapshot is an innovation, in my opinion. We will see how more it becomes an innovation. I have a lot of ideas. Let's see if we can
I
make them
really
happen.
like the acronym cryo because it reminds me of kind of cryogenically freezing the Docker container. It's like, you know, it's like flash freezing with liquid nitrogen or something, as you might do in the lab, and then resuscitating it in another place or another time.
It's a very good observation. I think that it's also true, but I don't remember. But what I can tell you is that I think that the people working on it, they are very edge in terms of details, and they are very compatible with how I think like someone should do things. No? So I was excited to work with them, and when we had things, we proposed patches to Cryo from Seqera. We found bugs, we fixed them, we helped fixing them, and they have been extremely reactive and proactive in finding new. For example, we sent a patch for an issue that we had for I think that there was some problem like snapshotting some parts of an RNA-seq pipeline and couldn't snapshot, and it was like coming as a ticket every day, and the only solution was to fix it in Cryo. As everyone does, I tried to cloud code it, but it didn't happen because it's almost impossible to provide the right context to AI for a bug like that. And not because it's not capable, quite the opposite, but it was impossible to prompt it correctly. And ended up writing a patch that was solving it, but was not getting to the root cause. They merged it was fixed, and usually like projects like they're all humans, like we move on. No, they started rewriting it, made a better version, solved the problem in a better way, more areas. So I was quite excited and happy to see that they take this so seriously, and so which is a very compatible, I would say, project to the way we envision stability and the way we envision making great software.
Yeah, I was going to say, I mean, we're both obviously kind of enthusiasts for open source software. Providing open source software to a community is how I usually see it happen, but it's nice to hear that we're also contributing back to other projects as well.
I agree. More than just agreement, I always tried to do that. Sometimes it's harder than other times because we also all have to live a life.
Yeah, you have several open source projects that you've released from Seqera, right? The things you've built in Seqera, which we've released as OSS.
Yeah, there is the one that I'm mostly proud, but is because it went unnoticed, is criu-static, no? Which comes from the pain point of being able to ship cryo in a way that because let me put it in this way. I like everything. I like all the computing, and I like a lot the model of macOS where, and also of Windows in a way, where everything gets shipped with your software. No, you just package it and it works. Makes things work, no? Because you don't need to install a library or have a shared. The whole concept of shared libraries for me is a bad idea, no, in a way, because it solves the problem of when there's a vulnerability in certain operating systems like Debian. It's incredibly good because they have a very good security team that is always on top of, and the software that you ship maybe is not. So I like that maybe the baseline operating system has this and the tool that you install via the package manager has this. But from our point of view of shipping software works for our users, it was impossible in a way to ship CRI-U with all the system libraries in a way that is perfectly linked in a pipeline of all the crazy things that our users do, because they come. One thing that I learned is that bioinformaticians, they are the power users of the power users of Unix tools and of tools. Like I see, I I've been programming in C for years, a lot of years, a decade at least. And I thought that I did interesting, no? Now it doesn't matter. The interesting C code. No? Then you look at tools that like others do, like like you look in the RNA-seq pipeline, you look at the tools that are in there, you're like, what is this? Like, how someone has this idea of doing this sequence of instructions and writes this code. Why? No? And you learn that is because they are amongst the most persistent people. They have to do a research. The research needs to be completed, and agency, intelligence, no? All in the same
Openness.
person. Exactly, they happen, and then they push to open source, and then you're mind blown. So, in this sense, I want to be able that all this craziness, no, that can have different requirements, always work. No, I don't want that you then when you run Fusion Snapshots and criu because it's in there, it doesn't work because as a base container you used something that is wild. No? And I don't also want to tell you, oh, you have to install this because otherwise Fusion Snapshot doesn't work. So we made criu-static, sent it to the mailing list. They still exist. And it got excitement, and so I'm very proud of it. There was also staticreg. I like the name static for some reason, and not on purpose. So when you are in a situation where you have to navigate all the craziness that comes out of running so many pipelines, and you build many different containers for them, etc. You want to be able to inspect them a little bit. Wave does that, but there was no way to actually navigate it via an UI. So we made this open source project that allows you to visualize a container registry, backed by Wave in this case, but any OCI container registry, and see what is inside. I believe that open source is very powerful. And I'm happy that also there is alignment on this in this company, because it's I'm somewhat also happy that Fusion Snapshot is not open source, because I did put really a lot of hacks into it. I'm joking. But Fusion Snapshot is extremely sophisticated. If you use it standalone, I don't think that any person listening to this use Fusion Snapshot use it standalone, like they just using the pipelines. Use it standalone. enable Fusion Snapshot in a pipeline, like go for it, like go on platform.
It's a tick box,
Enable
right?
Fusion Snapshot, and then get the Wave container that comes with it,
Hmm.
and Docker run it, no? On your laptop right now, if you are listening. And then you will have the binary Fusion Snapshot. Run a program with it, Fusion Snapshots, and top, no? And then send a CGAP signal to it with kill minus HUP process ID. You will see that the process completely terminates and create files. Now download those files on your computer, no? Forget about another computer, and now use Fusion Snapshots against that folder by setting Fusion work and the folder path as an environment variable, and now you're on Fusion Snapshots. Magically, the program appears exactly as it was before. Open VI and write hello, and then move the files. Start an instance on AWS, put the files there, and do this. You will see your program. It's mind-blowing. To make this happen, there was a lot of suffering and pain, but it's mind-blowing. The thing that I brought into it was my knowledge of namespaces, of Linux, of containers, of CRI, of everything. The idea was from Jordi. The original idea was from Jordi. He was extremely supportive in decluttering my thoughts so that it came out as the most lean, the most lightweight, the most... so it's... I'm very proud of it.
And practically speaking, the way that people, I mean, that walkthrough was really, I think, really interesting to sort of show. That's basically what's happening under the hood, right? You do the tick box in Seqera when you can create your compute environment to enable Fusion snapshots, and then the task is running on, could be AWS, but it works on other clouds as well, right? Or will do soon.
Yeah, we're working in GCP. Planning on Azure.
On Azure. And so the task is running on the cloud. And so the Spot instance that reclamation process happens. AWS sends a notification that this instance is going to be closed. And then Fusion Snapshots does its magic, freezes everything down. And then how does the system know when to start it off again? It's just the scheduler makes a new instance available again and picks it back up and restarts it.
This was already there if you think about it. What happens when you set max spot attempts is that Nextflow will create attempt 2 of the same task in the same work dir. What Fusion Snapshot does is that essentially it becomes the command run, essentially, before the command run of that task. It just executes the same command, but before executing it, it intercepts, checks if there was already an execution, and just
picks up where it left off.
Resumes it. Yeah, it's... I was mind blown now that it looked like what we built the past few years was thought with that in mind. No? With the kind of... in fact, the first version of Fusion Snapshots didn't require, I think still it is like that, any change in any other component. We just enriched the container with... when you enable Fusion, we add the Fusion to your container by injecting a layer via Wave. Because Wave had this ability to build your Docker files, but also allows you, for example, when you go and pick Conda packages, it creates the layers for you. It packages them so that when your computer or your Docker daemon downloads the definition, the manifest, it will see, oh, these are the layers, no? Which is essentially what container runtimes do. They build a set of layers so that you can download and then pack them together. Wave is even better because it allows you to set as a layer whatever is on a bucket on a URL, etc. So your task downloads those layers. We enrich with the Fusion and Fusion Snapshot naturally, no? And it just works.
Amazing.
And then when it's done, in the end, we have cleanup functions. We remove everything. Recently, we released incremental dumps because now the problem was that 2 minutes are not enough because remember, I don't know what your audience, the kind of research is doing your audience, but we have certain users that are, I want to be able to run a task that uses 200 gigas of memory. The kind of users that use the Seqera platform, so they are, again, crazy people, like to do crazy things because they have to solve crazy problems that nobody else has. So, using 200 gigas of memory, you can have the best machine you want, you can have the best network that you want, but moving this mastodontic thing to another machine is already a challenge. Moving it in under 2 minutes is a bigger challenge. So we are leveraging a feature in criu that allows you to take dumps that are incremental in time. We created our own an even more sophisticated system on top of it that is able to detect when it's the right moment. And usually, a timer is enough. But also when you do, let's say do it every 5 seconds, do it every 10 seconds, every 10 minutes, yes, you can do it. We do it with a timer now, but it has to detect if in that context of the Nextflow pipeline in the task is still a right moment to do it. What are the caveats? What is happening? Can it be done? Because one thing is doing it at the end when the machine is going away, you have no alternative. One thing is doing it while there was no need in terms of for the user, this is still a very good moment to not have any disruption in the pipeline. And we do this because we want to be able to capture the memory state and feeds it to the file system long before it starts becoming a problem, so that we already have a view. No? In fact, again, coming back to do the things on your terminal if you can. If you still have that container that we said before, run it with one of your task execution, you will find that there is also another binary called Fusion Snapshot Utils that contains a command line tool that allows you to view an HTML view, an actual graphical representation of your snapshot. So you see a graph with when was it taken, how many incremental dumps were taken, how much time did they take. So it's extremely useful for troubleshooting maybe why it's not doing it in time. No? And this is still something that we are not working on, but we are keeping on ears open because, again, you all out there it's not like you're all running websites, no? Or running inference for AI model. You are doing everything, no?
One of the things that really blows my mind that with Fusion Snapshots that you managed to make this work is how important it is to get the timing just right. Because you need to be able to take that snapshot and then not let the process run anymore. And so that when it restarts, the files on disk are perfectly in sync with the running process. Because if you have like a read aligner like BWA or something, and that's aligning probably millions of reads to the disk per second. And so how do you ensure that the timing is just right so that you don't duplicate any of those alignments, you don't have the same thing run twice, or you don't miss any?
The process, it's very, I would say, simple. No? The process gets frozen. No? There's a feature in the kernel called cgroup freezer. It's a freezer. The process gets completely frozen. It doesn't do anything anymore, and it's still there. This is done by criu. It's still a challenge for us, for snapshots, because criu starts from generic assumptions, while we, as again, I will say it again, we run very intense workloads that can do whatever they want. No, and usually, like even when you look at the documentation for criu and tools like that, you see that the kind of user that they have in mind is someone running an application that they know that they snapshots when they want. And now, more recently, it's being used a lot for AI inference, like to get the state of AI inference ready faster, completely different than our use. We use it so that you find the state and don't waste 20 minutes waiting for it again and redoing the same things over. All these features that they have, we are adapting them to work perfectly for this. And also, this was not possible without Fusion because luckily, no, we already had, again, other things that seemed like happening for a reason, no, that we already did a file system, spent years and years and years optimizing it, making it perfect. All of a sudden, it's perfect for this use case. No? And without it, it would have been a lot difficult to do the timing correctly. Because if you, in 2 minutes, have to dump everything to disk and then upload it, it's not enough time. Fusion is optimized in a sense that while you start writing on disk, it gets uploaded directly. And we are even thinking about completely bypassing, and have a pipe that goes directly from memory to S3. This is one of the next things.
Something I really like about the direction that Risk is going in is the kind of the fact that with the tooling that we're building in Seqera, we kind of own this full stack, right? And you see that in these kinds of conversations where you have Fusion Snapshots, which is built on Fusion, which is built on Wave, which is built on Nextflow, and you go all the way from Seqera platform, which is where the person actually interacts with it, and you tick a little box on a web page, which is the simplest thing in the world, and yet that has this effect all the way down, right down to the almost a kernel level of the absolute process stuff, and I think that's so cool that we can do that, and that we have the breadth of technical expertise and the breadth of product exposure that we can kind of implement these things.
Yeah, Seqera did a great job at getting together people from complete different backgrounds and have them work together.
Reminds me a little bit. You mentioned like Apple Macs a few times, and it sort of reminds me a little bit of how they approach things. That the MacBook body is machined out of aluminium to be exactly the right shape for the components. It kind of feels like the same thing. We're machining our own kind of computing components to fit around the shape of Nextflow and to make it work perfectly. Like it's hopefully clear to everyone listening that this is a pretty amazing thing that you've built. I'm in awe of it. I don't understand it, and I don't think I ever will, but I'm very happy that you've built it, and that it's going to make running on cloud faster and cheaper, probably significantly so, assuming that the spot market continues to go in this direction of being very frequently kind of interrupted and everything.
The thing that we missed is that we didn't ask everyone, to give it a try, because the way generally things work and evolve is if people, are actually going toward them and testing them and criticizing them and, telling what they see of value, what they don't like. Also, like Fusion Snapshots is reality doesn't like collect telemetries, for how you're using me, no. And so, ideally, no, seeing discussions, seeing conversations around it in the Nextflow Slack for me, and like if you want, like include me, like tag me at Lorenzo, because will give me, a way to know, no, if like we have pretty positive feedback from the customers that we tried this with, but I want to see, you know the bioinformatician person, like I want to come to the next summit, no, and talk with people that tell me, oh, Lorenzo, I tried it and I didn't like it because it did this thing, or I liked it because it did this other thing, but my specific, I don't know, I do one of the things that make me cry is the usage of pigz. And pigz is my enemy. No, it just because it does so many instructions that are like there was one problem. Let me tell you this, where pigz optimizes for a certain instruction set in x86. Then you move the workload to a better machine and it gets moved and everything is fine and it works. But if AWS Batch decides to then move the work to again to a worse machine, no, the snapshot process works and everything is fine, but pigz doesn't want to start because it decided that it has to use an instruction set in the meanwhile, which is not a pigz fault. Pigz didn't know that you were moving pigz around the different machines. But I literally had blood on my head because I keep on banging it to solve this. And usually all those, specific, archaic problems that don't make me sleep are all from pigz. Not pigz fault, because it's me that I'm doing something, different. But usually it's always pigz. Like if someone open a ticket and say, "Oh, Fusion Apps doesn't work," unless it's the usual because it didn't have enough time, so it's an optimization issue. It's pigz.
That's because pigz
So,
is optimized at such a low level for the different systems it can run on.
yeah, totally. It's just trying to pick the best instructions to reach a result. It's that which, from an engineering point of view, is the right thing to do. It's just well engineered and uses the compiler in the right way. They just put, I mean, if you think about it, it makes sense. Like you want your files to be compressed and uncompressed in the best way possible on this machine.
Yeah.
No, you don't want a generic solution. Otherwise, you would use a generic compression utility. No, you will use one that is less. No, compression is a nightmare.
Yeah.
Tar zip, they never give me a problem. pigz is
So if someone wants to try it out, I mean, I guess we just launched Seqera Compute and with 100 free credits. So the easiest way is to go and sign up and get that and spin up an environment on the cloud via Seqera Compute in a couple of clicks, tick Fusion snapshots and try running your pipelines. It's as simple as that.
Yeah. Ideally, there should be less buttons to click. Always, I like this approach from I got it from Michael, our colleague, Michael Dancy. He keeps on saying less buttons, less buttons. I pretty much like that. Like have less buttons, but now there is a button for it. So if you click it now and you tell me you tell us what you think, it will be amazing.
Very cool. Right. There's one more topic I wanted just to touch on because I think it's interesting, and I left it to the end because it's nice to think a little bit about conclusions of this is where we are now, this is state of the art. But as you said, things are moving so fast. With one eye to the future, knowing also that you and I are part of a secret group within Seqera called Claude Power Users, which I don't think many people know exists. So you're obviously a power user of AI, of code generation tools, and very very deep into that kind of world. Where do you see things going, broadly speaking? Like, how do you see things changing in the future, and where does Fusion, where does Nextflow, where does Seqera fit into this picture?
Today, the thing that is most important is to give the right context. It was always, but now it's the most important thing, even more than before, because I see it's going in a way where we are not gonna look at what it produced. No? So it needs to be careful, crafted, and can be handcrafted, but also can be that the tools that you use have to provide the right context. So providing the right context is, in my opinion, one focus that Seqera will have, providing to AI tools, giving the ability to iterate quickly on experiments will be paramount. And coming back to cloud and to usage, I think that it's finally the moment to create new things without being blocked by ourselves. So now we are relieved of this need to test and give all our energies to testing ideas and to do all of them perfectly. Now it's a moment when you can go quick and correct and right with the right, no? And maybe technologically we are not still there, still there is something, but we need to be prepared for when it will be. And I don't think that when it will be is in 2 years or in 6 months. I think it's this quarter likely, I don't like to make predictions, but I think that the sooner the mind changes and you enter in a situation where you get the personality for it. I always make this example. I made this example to everybody I know. Nobody here in this podcast knows me, but if you go and search my name on YouTube, you're gonna see I was like 130 kilos. I was like different. And I always told myself, oh no, I have to do a diet. That's the wrong thing to tell yourself, no? It's not a goal, no? Being on a diet is not a goal. The goal is to be healthy. The goal is to start doing every day, have the personality of someone who is healthy, so that being unhealthy becomes against your personality. So I think that in technology is the same thing. Like if you set an habit for yourself to use AI in a certain way, not like, oh, please AI, build me an Excel pipeline that sequences this DNA. That doesn't work. You have to put your brain, your knowledge into. But I think that if you are, like you all are, it's gonna be a lot different soon how you get to that result. I think that what happened to software engineers will go spread as oil to all the other fields where thinking is involved, because thinking is becoming the most important thing and not typing.
Typing. I like your diet analogy. It reminds me. It made me want to quote The Matrix, the film. You know, when you've got the kid with the spoon, and he's like, "You can't bend the spoon; you have to bend yourself." I like that.
Yeah.
Yeah, you know, the diet is not the objective. It's the losing weight in the long, or being healthy in the long run. And it's just, and with AI, you know, the objective is not to write one piece of code or write one pipeline. It's to change how you work.
And I think that with AI, we are gonna be able to define a new identity. And so if you feel that now some of your identity is going away because you cannot define yourself, I still define myself as a programmer, as a coder, as a developer. But the act of writing it, is likely now a hobby. It's not anymore the thing that I do most of my time in the day. And I realized that it freed a lot of time for thinking about actual problems, actual things, and multiply my impact, and the things that I do. Because I don't have to act willingly in detailing every single piece of the machine, which was also exhausting. I don't know how many nights I didn't sleep. It just for no reason. Like you then go to sleep at 6 a.m. and wake up at 7 a.m. to bring the kids to school. And what did you do? Configure the framework for doing that project that I have in mind. The next day, you are exhausted, the project dies.
Yeah. Well, that was a more philosophical note to end on than we usually go to the podcast, but I enjoyed it. It's nice to frame how we think about these things, and it's exciting times to live in. Lorenzo, thank you for joining me today. Thank you for going on.
Thank you for being awesome, Phil.
It's always a pleasure to chat. I never quite know what we're going to end up talking about, but that's what I like about chatting to you. It's always an exciting experience. And yeah, everyone who's listened to this podcast, thanks very much. Give Fusion Snapshots a try. Tell us what you think. You'll make, even if you're submitting a bug report, you'll still make Lorenzo happy.
Yeah, I look to the tickets just for the Fusion Snapshot bugs, and when they are not there, I'm a little bit sad.
Exactly.
It's like the heartbeat,
Exactly. Yeah. All right. Thanks very much, Lorenzo. Thanks everyone for listening, and see you all soon.
Thank you.